Have you ever looked into the night sky and wondered whether you're looking at the present or the distant past? It sounds impossible, yet every star you see is sending you a message that began its journey long before this moment. Some of that light started traveling before the first cities were built. Some left its star before humans even existed. And some of the faintest galaxies visible through powerful telescopes are so distant that their light began its journey billions of years ago, when our own solar system had not yet formed. Every time you look upward, you are becoming a traveler through time. But that is only the beginning of the mystery. Imagine a universe so vast that our entire planet is less than a grain of sand on an endless beach. A universe filled with stars larger than our sun by hundreds of times. Invisible matter holding galaxies together. Black holes capable of bending space and time. And worlds where the skies would look unlike anything you've ever imagined. The deeper we explore, the more astonishing reality becomes. This is not simply a story about planets and stars. It is the story of everything that has ever existed, from the birth of time itself to the endless future stretching beyond imagination. So prepare to leave Earth behind, silence every distraction, and open your mind to the greatest adventure ever undertaken. Welcome to exploring the endless cosmos, where every chapter takes us farther into the universe than ever before, revealing wonders that continue to challenge everything we think we know about reality. Long before there were galaxies shining across the darkness, before planets circled distant stars, and before even the first atoms existed, the universe was unlike anything we can truly imagine today. There were no mountains, no oceans, no light, and no empty space waiting to be filled. Everything that would one day become every star, every planet, every galaxy, and every living creature was compressed into an unimaginably hot and incredibly dense state. Then, approximately 13.8 billion years ago, the universe began expanding. Contrary to popular imagination, this was not an explosion occurring inside empty space. Space itself began expanding in every direction simultaneously. Time, matter, energy, and the very fabric of reality emerged together, marking the beginning of the greatest story ever told. During the first tiny fraction of a second, the universe expanded at an astonishing rate. Temperatures were so extreme that nothing resembling ordinary matter could exist. Energy dominated everything. As expansion continued, the universe gradually cooled, allowing the first fundamental particles to form. Tiny particles collided endlessly in an unimaginably energetic environment. Eventually, these particles combined to create the first atomic nuclei, primarily hydrogen and helium, the simplest and lightest elements in existence. Yet, despite their formation, the universe remained completely dark. There were still no stars to illuminate the growing cosmos. For hundreds of millions of years, enormous clouds of hydrogen and helium drifted silently through expanding space. Gravity, though incredibly weak over small distances, slowly became the architect of the universe. Regions containing slightly more matter than their surroundings attracted additional material. Over immense stretches of time, these clouds collapsed under their own gravity. As they contracted, pressure and temperature inside them rose dramatically until something extraordinary happened. Nuclear fusion ignited. The first stars burst into existence, ending the universe's long period of darkness and filling space with light for the very first time. These ancient stars were unlike many we see today. Many were enormous, containing dozens or even hundreds of times the mass of our sun. Because of their tremendous size, they burned through their nuclear fuel rapidly. Deep inside their blazing cores, hydrogen atoms fused together into helium, releasing incredible amounts of energy. As they aged, these stellar furnaces began producing heavier elements, including carbon, oxygen, silicon, magnesium, and iron. Every breath you take today depends on oxygen forged inside stars, the calcium strengthening your bones, the iron flowing through your blood, and the carbon forming every cell of your body, all originated inside stars that lived and died billions of years before Earth existed. In the most literal sense, we are made from the ashes of ancient suns. Eventually, these massive stars reach the ends of their lives in spectacular explosions known as supernovae. For brief moments, a single exploding star could outshine an entire galaxy. These powerful explosions scattered newly created elements across enormous regions of space, enriching vast clouds of gas and dust. Instead of ending the story, each supernova became the beginning of countless new ones. The material expelled into space mixed with other clouds, providing the ingredients for future generations of stars, planets, and eventually life itself. The universe became a place of constant renewal, where destruction and creation work together in an endless cosmic cycle. Billions of years later, within one of these enriched clouds, our own solar system began to form. Gravity once again gathered enormous quantities of gas and dust toward a common center. Most of this material collapsed into the young sun, while the remaining matter flattened into a spinning disk surrounding it. Tiny grains of dust collided gently at first, sticking together through electrostatic forces. Over millions of years, these particles became pebbles, then rocks, then mountain-sized bodies. Through countless collisions, they eventually formed planets. Some became rocky worlds close to the sun. Others accumulated enormous amounts of gas, growing into giant planets whose sizes dwarf Earth many times over. Among these newly formed worlds, one occupied a particularly fortunate position. Earth orbited at a distance where temperatures allowed liquid water to remain stable across much of its surface. Its atmosphere evolved to protect life from harmful radiation while retaining enough warmth for oceans to exist. Deep beneath the surface, geological activity recycled essential materials, while the presence of the moon helped stabilize Earth's rotation, creating a relatively stable climate over immense periods of time. Countless unlikely events combined to transform an ordinary rocky planet into the only known world where life has flourished. Yet, when viewed from space, Earth appears astonishingly fragile. From hundreds of thousands of kilometers away, national borders disappear. Cities become invisible. The entire history of civilization occupies only the thinnest layer surrounding a small blue sphere, drifting through the darkness. Every war ever fought, every scientific discovery ever made, every piece of music ever composed, and every human life that has ever existed has unfolded on this tiny world suspended in an unimaginably vast universe. Perhaps that is one of the greatest gifts astronomy offers us. The farther we look into space, the more clearly we understand our own home. The universe humbles us without diminishing us. It reminds us that although humanity occupies only a tiny corner of the cosmos, we possess something extraordinary, the ability to ask questions about the universe itself. We are pieces of the cosmos that have become aware of the cosmos through curiosity, observation, and science. The universe has developed a way to explore its own existence. But our journey is only beginning. Ahead lie the remarkable worlds of our solar system, stars far stranger than our own sun, mysterious black holes that distort space and time, galaxies containing trillions of stars, and cosmic structures so enormous they stretch beyond the limits of ordinary imagination. Every step deeper into exploring the endless cosmos reveals another breathtaking truth, no matter how much we discover. The universe always remains even more extraordinary than we expected. Our journey now brings us to the place humanity knows better than any other corner of the universe, our own solar system. Although it occupies only a tiny fraction of the Milky Way, it is an extraordinary laboratory where nearly every type of planetary environment can be found. Here, blazing worlds orbit dangerously close to the Sun, while frozen giants circle in darkness billions of kilometers away. Violent storms rage for centuries on some planets, while others have remained almost unchanged since the birth of the solar system itself. Every planet, moon, asteroid, and comet tells a different chapter in the story of cosmic evolution. Together, they reveal how the same laws of physics can create worlds that are astonishingly different from one another. At the center of this remarkable system burns the Sun, an ordinary-looking star that is anything but ordinary. Every second, it converts hundreds of millions of tons of hydrogen into helium through nuclear fusion. The energy released during this process radiates outward, taking thousands of years to travel from the Sun's core to its surface. Once it escapes into space as sunlight, it reaches Earth in just over 8 minutes. Every sunrise you have ever witnessed is powered by reactions that began deep inside the Sun, long before human civilization existed. Without this continuous flow of energy, Earth would become a frozen, lifeless world drifting silently through darkness. Despite dominating our daily lives, the Sun is only a middle-aged star. It has been shining for approximately 4.6 billion years and is expected to continue doing so for roughly another 5 billion years. During that time, it will gradually become brighter as it consumes its hydrogen fuel. Eventually, its core will begin to change, causing the Sun to expand into a red giant. The inner planets will experience dramatic transformations, and the familiar solar system we know today will cease to exist in its current form. Yet, even this incredible future is only one chapter in the life cycle of an ordinary star. Closest to the Sun is Mercury, a small rocky planet covered in countless impact craters. It has almost no atmosphere to protect its surface, leaving it exposed to intense solar radiation and dramatic temperature changes. During the day, the surface becomes hot enough to melt certain metals. At night, with no atmosphere to trap heat, temperatures plunge far below freezing. Mercury reminds us that distance from a star is only one factor determining a world's environment. Atmospheres, magnetic fields, and geological activity all play equally important roles. Next comes Venus, often called Earth's sister because of its similar size and composition. But beneath its thick clouds lies one of the most hostile environments in the solar system. Its dense atmosphere is composed mostly of carbon dioxide, creating an extreme greenhouse effect that traps enormous amounts of heat. Surface temperatures become hot enough to melt lead. Crushing atmospheric pressure and corrosive clouds make Venus one of the least hospitable places imaginable. Yet scientists continue studying it because it offers valuable clues about how planetary climates can evolve in dramatically different directions. Earth, by comparison, appears almost miraculous. Its atmosphere contains the precise mixture of gases needed to support complex life. Liquid water covers much of its surface. A magnetic field shields the planet from harmful charged particles streaming from the Sun. Plate tectonics recycle nutrients and help regulate long-term climate. Every feature works together in a delicate balance that has allowed life to flourish for billions of years. Although Earth may seem ordinary to those who live here, viewed against the backdrop of the cosmos, it is one of the rarest and most remarkable worlds we know. Beyond Earth lies Mars, the red planet. Today it is cold, dry, and windswept, but evidence preserved in its rocks suggests a dramatically different past. Ancient river valleys, lake beds, and minerals formed in the presence of water indicate that billions of years ago, Mars possessed flowing rivers and perhaps even vast lakes. Whether simple life ever emerged there remains one of the greatest unanswered questions in planetary science. Robotic explorers continue examining its surface, collecting samples and searching for chemical signatures that might reveal whether life once existed beyond Earth. Farther outward, the landscape changes dramatically. Jupiter towers above every other planet, containing more mass than all the remaining planets combined. It is not a solid world, but an immense sphere of hydrogen and helium surrounding a dense interior. Its atmosphere hosts storms unlike anything seen on Earth. The Great Red Spot, a gigantic storm system larger than our entire planet, has persisted for centuries. Lightning flashes through towering clouds, while powerful magnetic fields generate intense radiation surrounding the giant planet. Jupiter is accompanied by an extraordinary family of moons. Among them is Europa, whose smooth icy surface conceals a global ocean beneath. Scientists believe this hidden ocean contains more liquid water than all of Earth's oceans combined. Deep below the ice, tidal forces generated by Jupiter's gravity may provide enough heat to keep the water liquid. If life can exist in such hidden oceans, then habitable environments may be far more common throughout the universe than we once believed. Saturn follows with its breathtaking system of rings stretching hundreds of thousands of kilometers into space while remaining astonishingly thin. Each ring consists of countless fragments of ice and rock orbiting together in perfect harmony. Though they appear solid from a distance, they are more like an immense swarm of tiny worlds circling the planet. Saturn's moon Titan is equally fascinating. It possesses a thick atmosphere and rivers, lakes, and seas, not of water, but of liquid methane and ethane. It demonstrates that weather, rainfall, and erosion can occur using completely different substances under entirely different conditions. Beyond Saturn lie Uranus and Neptune, the icy giants. Here the sun appears as an exceptionally bright star rather than the dominant object filling the sky. Temperatures plunge to extraordinary lows, yet these distant planets remain surprisingly active. Neptune's winds are among the fastest measured anywhere in the solar system, racing through its atmosphere at speeds far exceeding the strongest hurricanes on Earth. Uranus presents another mystery. Unlike every other major planet, it rotates almost completely on its side, likely the result of a colossal collision early in the solar system's history. Past Neptune stretches a frozen frontier filled with dwarf planets, icy bodies, and ancient remnants left over from planetary formation. Objects such as Pluto preserve a record of the solar system's earliest days, largely untouched for billions of years. Every comet that occasionally visits the inner solar system carries with it material older than Earth itself, acting as a messenger from a time when planets were still forming from clouds of dust and gas. Yet, remarkable as our solar system may be, it is only one planetary system among countless others scattered throughout the Milky Way. Every year, astronomers discover new worlds orbiting distant stars, planets larger than Jupiter's, rocky worlds resembling Earth, scorching worlds hugging their stars, and frozen planets drifting alone through interstellar space. The realization is breathtaking. Our solar system is not unique. It is one example among billions, and somewhere among those distant stars may exist worlds where another civilization has looked toward the heavens and begun asking the very same questions that inspire our own journey through exploring the endless cosmos.